metal ions. So there's no specific nonmetal given here, so I'm just going to give it the symbol capital N, lowercase m for nonmetal. And what they're saying is when the atom, now we know that atoms are neutral. Atoms are neutral because they have an equal number of protons and electrons. Therefore, their oxidation states are always going to be 0. Now, a nonmetal ion, it says, is going to form a negative ion. So we're just going to put a negative sign here. Now, what we see is this oxidation number is going down. And when anything goes down, like the price of a shirt at a store, it is reduced. So this is reduction. For the next question, we're just going to pull up a square so that we have a little bit of place to do some work. So what I'm going to do is I'm going to separate this equation into its two halves, looking at each species or element separately. So we have chromium, which is a +3, changing to a chromium, which has no oxidation state. Remember, anything with no oxidation state by itself is always 0. And we have aluminum with no oxidation state. Again, that must be 0, becoming an aluminum ion with a charge of +3. And ask, in this equation, how are the electrons transferred? So when we look just at oxidation numbers, we see that chromium is going from 3 to 0. It's being reduced. That means that it's gaining electrons. We can remember that the gain of electrons is reduction. And since aluminum's oxidation number is going up from 0 to 3, then it's undergoing oxidation. The loss of electrons is oxidation. So that means that aluminum is losing its electrons and it's going to give its electrons to chromium. Now it is important that you also recall that protons, which are located in the nucleus of an atom, are never changed in a chemical reaction. They're only changed in nuclear reactions. So choice 3 and 4 are not good. And again, remember that we have established that aluminum is losing the electrons and giving them to chromium. So the electrons go from aluminum to chromium. In the next question, we're looking for the oxidation half reaction. Recall that the loss of electrons is oxidation. We can also remember that the gain of electrons is reduction. That means that when we gain electrons, the oxidation number goes down. And when we lose electrons, the oxidation number goes up. So here we're looking for something to increase in oxidation number. So here, let's look in the first example. We have the oxidation number going from 0 to 2. So that appears to be oxidation. Let's look at the other choices. The next choice, it goes from 0 to 2 also. So here we have two possibilities. We have the same change going from 0 to 2. Now let's look at choice 3 and 4. Choice 4, we have an oxidation state going from 2 to 0. Remember that anything by itself has an oxidation state of 0. And copper is going from 2 to 0. So 2 to 0 is a reduction in oxidation number. So that's not the correct answer. So now we're between 1 and 2. We have to make sure that 1 and 2 make sense, or mathematically they're correct. In choice 1, we have 0 plus -2 equals +2. That doesn't seem right, so that can't be the choice. So choice 2 must be our answer because 0 equals, remember that this arrow is like an equal sign, +2 plus -2. Because that's right, that's our best choice. Now, in question number 7, we're given a chemical equation and we're asked which species undergoes reduction. Again, we're going to refer up here to the loss of electrons is oxidation and the gain of electrons is reduction. And a reduction means something is decreased, so our oxidation number will go down. So what we have to do is assign oxidation numbers. Again, anything by itself in its natural state has an oxidation state of 0. So aluminum here has an oxidation state of 0. Here we have iron oxide. Now, when we look on our reference table at the periodic table, oxygen only has one oxidation state of -2. But iron has two oxidation states, a +2 and a -3. So that means we must calculate the oxidation state here. Now, so we'll just temporarily call this X. Recall that we have to have the sum of the oxidation numbers to equal 0. So that sets up the mathematical formula where 2x for the iron and 3 times -2 have to equal 0. So this makes it so that X has to be +3. So our iron here is an oxidation state of +3. As we continue to go and look at oxidation numbers, we'll go to the iron on the product side, which is by itself. So its oxidation state is 0. Now, oxygen in aluminum oxide can only have an oxidation state of -2, and aluminum, from our reference table, can only have an oxidation state of +2. So here, again, we're looking for someone whose oxidation number goes down. Aluminum's oxidation number went from 0 to 3. That's not a reduction. Iron's oxidation number went from 3 to 0. That is a reduction. So iron on the reactant side is actually iron +3. So choice 4 is our best answer. Now, another really helpful hint is when they're asking which species undergoes oxidation or reduction, we're always going to be referring to the reactant side, or the left side of the chemical equation. In question number 11, we're looking for oxidation. So again, we go back to our trusty memory device. Leo, the lion, says grr. That means that the loss of electrons is oxidation, and the gain of electrons is reduction. And the reason why a gain of electrons is called reduction is because the oxidation number goes down. While in oxidation, the opposite must be true. The oxidation number goes up. So since we're looking for oxidation, we're looking for an increase in oxidation number. So first we have to assign oxidation number to all the species. Recall that if no oxidation number is given, it is assumed to be 0. So in the first question or choice, we have aluminum, which has an oxidation number of 0 because it's by itself and nothing is given. And here aluminum, the atom with the oxidation state of 0, is going to be forming an aluminum ion with an oxidation state of +3. In the next choice, we again have aluminum going from 0 to +3. Choice 3, we have oxygen by itself. It's not important that it's diatomic or that it has the subscript 2, because that always has to happen. So oxygen is going from 0 to -2. And then in the final answer choice, again, we're going from 0 to -2. Reading back in the question, we're looking for oxidation, so it can't be choice 3 or choice 4. Now, looking at choice 1 and 2, we have to find out which one is correct. Now, we have 2 clues. The loss of electrons is oxidation. Recall that in a chemical equation, anything gained will appear on the reactant side or the left side of the arrow, while anything lost will appear on the product side or the right side of the arrow. So that basically means that my electrons that I'm losing need to be on the right side of my arrow. But I can also double check this with math. So when I look at the oxidation numbers here, the first choice says 0 plus -3 equals +3, and that's not correct. But in choice 2, it says 0 equals +3 plus -3. Again, recall that the arrow symbolizes an equal sign. And the reason why we have the same value summing on both sides of the chemical reaction is because matter, electrons, or charge can never be created or destroyed, but it is always conserved. That leads us to the next question, which basically tests your knowledge of the law of conservation of mass and the law of conservation of energy or charge. So here we want to make sure that mass, or the number of atoms, and charge, the total oxidation states, are the same on both sides of the equation. Choice number 1, we have chlorine. We have 2 chlorines on the reactant side, but only 1 chlorine on the product side. So this, in just simple terms of atoms, is not balanced. In choice 2, we have 1 copper atom and 1 copper ion on each side of the arrow. And then we have 2 silver ions, but only 1 silver atom. Again, this discrepancy in number means that this can't be balanced. Now, in the next 2 equations, we'll see that according to atoms, they're balanced on both sides. I have 1 zinc on the reactant side and 1 zinc on the product side. 1 chromium on the reactant side and 1 chromium on the product side. So according to atoms, it's balanced. Now, when I look at choice 4, the same is true. 1 nickel, 1 nickel. 1 lead, 1 lead. So now we have to see how they are different. And the way in which they're different are the charges. So in 3, the total charges here are going to be 0 plus 3. That equals 3. And remember that this arrow is like an equal sign. And then we have 2 plus 0, or 2. That's not true, so this can't be the answer. Let's see why 4 is our best choice. Here we have nickel, which is 0, plus lead, 2. 2 equals 2 plus 0, 2. So this has the conservation of both atoms and charge. Question 13 is very easy to answer with a simple look at our chemistry reference table directly on the periodic table. Here we're asked, what is the oxidation number of oxygen in aluminum oxide? Now when we look on our reference table, oxygen is here, and it only has 1 selected oxidation state. So in a compound, oxygen only ever has the oxidation state of -2. Finally, it asks us to write a balanced oxidation half reaction for the oxidation reduction reaction. Now, it's really important that you only write a half reaction, which means you only talk about one element, the element undergoing oxidation, and you don't write a balanced reaction or talk about both elements. So here, we recall that the loss of electrons is oxidation, so our oxidation number must go up. So we'll start by assigning the oxidation number of all of the elements in the equation. We start with aluminum. It's by itself, so its oxidation number is 0. And then we go to oxygen, where again it's by itself, so its oxidation number is 0. In aluminum oxide, oxygen has an oxidation number of -2 from our periodic table. Again, in our periodic table, aluminum here, element number 13, only has 1 oxidation number, +3. So when we want to see what's undergoing oxidation or reduction, we're going to see that aluminum goes from 0 to 3. That is an increase in oxidation number, so aluminum is oxidized, while oxygen, which goes from 0 to -2, is being reduced. So what we'll do to write the half reaction is we'll write the symbol separated by an arrow. So we'll write aluminum on both sides of the arrow, and then we'll include the oxidation number from the reaction. So the oxidation number of aluminum began as 0, and it ended as +3. Now this equation is balanced in terms of atoms because I have 1 aluminum on the reactant side and 1 aluminum on the product side. But it is not balanced in terms of charge because 0 does not equal 3. So we must balance the charge by adding in electrons. We always add electrons to the more positive side because electrons have a negative charge. So in order to make this mathematical expression true, I'm going to add 3 electrons. To determine the number of electrons that you need to add in any oxidation or reduction reaction, simply take the difference between the 2 oxidation numbers. We double check our work and make sure that this is true. 0 equals +3 plus -3. Very good.